Pluto and Neptune on a potential collision course? Scientists sound the alarm. Pluto, the enigmatic dwarf planet dwelling in the outer reaches of our solar system, is once again stirring excitement in the astronomical community. Recent findings suggest a potential close encounter with Neptune, raising serious concerns among scientists and space enthusiasts alike. Renowned astrophysicists, including Neil deGrasse Tyson and Miyoku, have issued warnings about the possible consequences of the celestial confrontation. How did Pluto reach this point? Once considered the ninth planet, Pluto was reclassified as a dwarf planet due to its small size and unusual orbital behavior. Yet this demotion hasn't dimmed its scientific intrigue. Its eccentric, tilted orbit has long fascinated researchers, and new simulations indicate a concerning overlap with Neptune's trajectory. Pluto's orbit around the Sun takes about 248 Earth years to complete, and since its discovery in 1930, it still hasn't finished one full revolution. Unlike the nearly circular orbits of the major planets, Pluto's path is highly elliptical and tilted at 17 degrees relative to the solar system's main plane, known as the ecliptic. Interestingly, for about 20 years in every orbit, Pluto actually travels closer to the Sun than Neptune. This seems like a recipe for disaster, yet no collisions have occurred. Why? The protective forces at play. The key lies in the gravitational choreography of the solar system. Despite their overlapping orbits, Pluto and Neptune are locked in precise 3:2 orbital resonance, meaning Pluto completes 2 orbits for every 3 of Neptune's. This dynamic helps maintain their distance and prevent impacts. Moreover, Pluto is always at least 90 degrees away from Neptune when their orbits intersect, thanks to a stabilizing phenomenon known as libration. This alignment ensures that Pluto stays above or below Neptune's orbital plane during close approaches, acting as a built-in safety mechanism. The chaos within order. Still, Pluto's orbit isn't entirely predictable. Simulations from the late 1980s revealed that while the dwarf planet appears to move in a stable pattern, its orbit is technically chaotic. Minor changes in initial conditions, like speed or position, can lead to significant deviations over millions of years. This chaos is governed by the three-body problem, which explores the gravitational interactions between 3 celestial objects. In this case, Pluto, Neptune, and the Sun researchers have used terms like IML vibration and Kozai oscillations to explain how Pluto manages to avoid collisions despite its seemingly erratic path. The role of the giant planets. The massive gravitational fields of Jupiter and Saturn also influence Pluto's orbit. Jupiter's immense pull helps stabilize outer solar system objects, while Saturn, though less influential, contributes to the overall gravitational balance. Together, Neptune, Jupiter, and Saturn form a gravitational web that preserves Pluto's motion for billions of years. This delicate balance is crucial. Without it, the solar system could descend into chaos, with celestial bodies knocked on their paths or even ejected into space. What does this mean for Earth? The idea of Pluto colliding with Neptune may sound far-fetched, but it reflects the broader uncertainties of celestial mechanics. While current models suggest that such a collision is extremely unlikely, ongoing research and simulations are essential. Even small miscalculations in initial data can dramatically alter long-term forecasts. Astrophysicists emphasize that while the risk is minimal, it underscores how much remains unknown. Pluto's complex journey serves as a reminder of the unpredictable beauty of the cosmos. Neil deGrasse Tyson's perspective. Neil deGrasse Tyson, who famously advocated for Pluto's reclassification as a dwarf planet, continues to be a leading voice in space science. He views Pluto not as downgraded, but as rightly categorized within our evolving understanding of the solar system. To Tyson, Pluto's peculiar orbit is a source of wonder and a perfect example of how celestial mechanics defy simple explanations. He sees a public fascination with Pluto and space anomalies like potential planetary collisions as an opportunity to engage people with science and spark curiosity about the universe. Conclusion: Pluto's strange and complex orbit continues to intrigue astronomers and challenge our understanding of celestial dynamics. Though a collision with Neptune remains unlikely thanks to gravitational resonances and orbital protections, the very possibility highlights the dynamic and sometimes chaotic nature of our solar system. As simulations evolve and knowledge deepens, Pluto reminds us of how much we still have to learn about the cosmic dance taking place right above our heads. The potential risks of Pluto's unusual orbit and a hypothetical collision with Neptune. After years of studying Pluto, concerns have emerged over the stability of its orbit, particularly in the context of the three-body problem, a complex gravitational interaction involving multiple celestial bodies. Some experts suggest that a long-overdue collision between Pluto and Neptune could be more than a theoretical possibility. Renowned astrophysicist Neil deGrasse Tyson has raised alarms about the implications of such an event. He warns that a collision between Pluto and Neptune would not only disrupt the orbital dynamics of our solar system, but could also have cascading effects on the cosmic balance, potentially with consequences reaching as far as Earth. While a direct impact on our planet is highly unlikely due to the vast distance, the sheer energy of collision could be devastating. Given Pluto's smaller size and icy composition, it would likely be obliterated upon impact, scattering debris across the solar system. This debris could pose risks to other planets and their moons, while Neptune's atmosphere and orbital path might also be significantly altered depending on the specifics of the collision. Theoretical physicist Michio Kaku, known for his contributions to string theory and popular science communication, offers a broader perspective. He views Pluto's orbital behavior as more than just a curiosity. It is a window into the future of space exploration and our understanding of celestial mechanics. According to Kaku, studying Pluto's orbit helps us grasp the intricate gravitational relationships between celestial bodies, which is essential for navigating and planning future missions to the outer solar system and beyond. Kaku emphasizes that these gravitational interactions, such as a delicate dance between Pluto and Neptune, are not isolated events. Instead, they reflect deeper principles of physics, tying celestial motion to the core ideas of string theory. In the event of a collision between Pluto and Neptune, the astronomical observations could create extreme conditions involving intense gravity and energy, ideal for testing predictions in string theory. For instance, the resulting gravitational waves could offer rare data on how space-time behaves under such extremes, potentially advancing our understanding of the universe's fundamental structure. Though Earth will remain safe from any direct physical effects, the scientific ramifications of such an event could be enormous. It would offer a rare and possibly unprecedented opportunity to observe real-time data supporting or challenging current theoretical physics models. Pluto's orbit is a compelling example of the fragile balance between stability and chaos in celestial mechanics. Its eccentric trajectory, shaped heavily by Neptune's gravitational pull, reflects the intricate and dynamic architecture of our solar system. The three-body problem, which helps explain these interactions, continues to puzzle scientists and plays a key role in predicting planetary motion. In planetary systems like TRAPPIST-1, home to 7 Earth-sized exoplanets, the same principles apply. While actual planetary collisions are rare, they are not beyond the realm of possibility. Understanding how gravitational forces influence orbital paths is essential for both safeguarding future space missions and advancing our knowledge of the cosmos. Ultimately, Pluto's strange path may hold more than just scientific intrigue. It may serve as a cosmic clue to some of the universe's deepest mysteries. This pushes us to more advanced research and driven by a shared desire to understand most important, highlights the ever-evolving nature of science and discovers constantly one related concept, deals with how matter this discussion about scientists track of some regions of space are galaxies, while others are largely light. Scientists from various one set of band light source distance phenomenon known as this allows scientists to in other cosmic microwave vast. NASA takes your vein after how much travel by studying CNS. Researchers gain insight into photographs like the second large pyramid. However, this data doesn't align with large the uneven gravitational pattern early CNS data in 2000. This mismatch actually possibly tied to according to Rice and leading scientists, whether the Hubble Space Telescope might have JWST confirmed the same described as there's a fundamental flaw in our understanding of gravity hiding between these observations. Rice says that we have strong connection thanks to JWST's powerful infrared. Researchers can now compare deeper space and study cosmos yet despite this progress, dark matter and dark remain shrouded in mystery, while black holes evolve into primary power and attention are now being paid to dark matter might also as scientists continue to analyze the foundations of modern cosmology are undergoing serious scrutiny. The telescope's ability to measure galaxies challenge existing some early universes massive galaxies and this suggests one of two possibilities. Either galaxies now or our understanding of physical laws governing early universe one emerging idea involves adjusting the standard framework in cosmology. It includes cold dark energy, cosmological lambda representing dark energy. Some physicists now speculate that dark energy vary over time and interact with dark matter in ways we don't yet understand. This evolving form of dark energy, often called catastrophe, to explain why cosmic expansion rates differ across time periods. Other researchers are investigating alternative theories of gravity, such as modified Newtonian dynamics or scalar tensor theories, which tweak Einstein's general relativity on cosmic scales. These models aim to address the gaps and tensions in current observations, offering new ways to explain the universe's most puzzling phenomena. Public interest under Saturn's ring, breathtaking solar solar telescope. NASA's attention to balance new planets like the Hubble Space Telescope and the Mars showing strange. Still, without Voyager pressed chaos could reign. Traveling nearly every miles a day, orbital Saturn's widespread unknown edge of science. Neil deGrasse Tyson and compelling insight. Only moon in the solar system with a thick known for famously championing the reclassification of Pluto as a dwarf planet. Tyson doesn't see this as a demotion, but as an acknowledgement of our evolving understanding of celestial mechanics. He emphasizes that orbits like Pluto's, steep, elliptical, and chaotic, are reminders of how much we still have to learn about the universe. Tyson often highlights how public interest in topics like Pluto's orbit can serve as a powerful gateway to scientific curiosity. By engaging with the unusual and sometimes illogical nature of space, people are invited to appreciate the beauty and complexity of our cosmos. Pluto, in all its orbital oddity, exemplifies that. Despite the alarms raised by some researchers, the general consensus remains. While Pluto's orbit is indeed chaotic and unique, it is highly unlikely to collide with Neptune in the foreseeable future. Still, the very possibility, however slim, serves as a potent reminder of how fragile cosmic order can be. Continuous observation, advanced simulations, and refined models are essential to maintaining our understanding of the solar system's delicate balance. Pluto's curious path may not pose an immediate threat, but it continues to challenge our assumptions and deepen our appreciation of the vast and dynamic system we call home.